In this lesson on addition and subtraction equations, we're going to apply the properties of equality, the addition and subtraction properties of equality, which state that you can add or subtract the same amount from both sides of an equation, and the equation is still true. And of course, we're going to apply this with rational numbers, so we're going to have mixed numbers and fractions and decimals and positives and negatives in our equations as we kind of extend your skills from what you had previously learned. So in the next couple slides, we're going to take a look at some examples of applying the addition and subtraction properties of equality. Our first equation is n plus negative 4 equals 12. The goal here is to get this letter n all by itself equal to some certain number. And we can do that by getting this negative 4 to be a 0. But however we do that on the left side to get negative 4 to be a 0, we have to do the same thing over here. So we're going to add or subtract something, combine negative 4 with something with using addition or subtraction to get a 0. So there's a couple ways to do this. We could actually add a positive 4, and that makes a 0 pair. But if we add a positive 4 to the left side, we have to add it to the right side, so we're going to put plus 4 here. It's the same deal where I tell you to copy the equation, step 1, copy the equation, step 2, do something to add or subtract something. In this case, in the lesson today, it's adding and subtracting something in order to get the variable to be all by itself, to get an n all by itself. And then you have to do the same thing to both sides. So this would be a 0 pair. The negative 4 plus positive 4 is 0, leaving us with n equals 16. So we're going to think, is it true? Does it make sense that 16 plus negative 4 is negative 12? But sure enough it is. The difference between 16 and 4 is 12, and there's more positives than negatives. In this example, you're probably going to need to do some work on the side, and this is how you can set your papers up. You can copy the equation on the left side of your paper, do the work, cover up the A, and you'll see subtract 1 1/4. Do the opposite, which is add 1 1/4. You have to add it to both sides. Go to that section, 1 1/4. And unless you're really good, you're not going to have to do some work on the side to do 6 2/3 plus 1 1/4. But you think about what's a common denominator for 3 and 4. Count by 4s. 4 doesn't work. 3 doesn't go into 4. 8 doesn't work. 3 doesn't go into 8. But 12 works because it's 3 times 4 is 12. So we're going to say that's 6. And don't forget to write that 6 when you do this. And when you say here over here, don't forget to put 1, because you don't want to write that 6 is equal to 8. I mean that 6 and 2/3 equals 8/12. It doesn't. It equals 6 and 8/12. And 1 1/4 equals 1 3/12. Here multiplied by 3 and by 3, and here multiplied by 4 and multiplied 2 times 4 to get that answer. So we're ready to go. 8 and 3 makes 11, and it's 7 and 11/12. So this is a 0 pair. A equals 7 and 11/12. In another example with fractions, we have x minus negative 4 7/8 equals 2 6. So there's a simple manipulation that would make this problem simpler from the get-go. And that is to make it add the opposite. Instead of doing subtract negative 4 7/8, make it add positive 4 7/8. Then we would do the opposite of adding 4 7/8, which is to subtract 4 7/8. Easy to do on this side, but it's going to be a little complicated over here. But, this is a little bit like 2 minus 4. We're going to make it plus negative 4. And this is a 0 pair, so on the left side we have x. And when you have a positive and a negative combined, you have to find the difference between the two numbers. So I have to do 4 7/8 minus 2 1/6. I think in most of the examples we've done so far, you just had to multiply the numerator times the denominator to get and it always works to find a common denominator. I can say 8 times 6 is 48. But in this case, there is actually a smaller one. The least common denominator is not 48. If I count by 8s, I would go 8. 6 doesn't go into 8, so that doesn't work. 8 times 2 is 16. I'll try 6 into 16. That doesn't work. 8 times 3 is 24, and that's what I want, because 6 will go into 24 4 times. And it tells me my numerator here is 4. 8 goes into 24 3 times, so I have to multiply it by 3. And then I'm ready to subtract, and 21 minus 4 is 17 over 24, and 4 minus 2 is 2. So I know that it's going to have an absolute value of 2. My answer is an absolute value of 2 and 17 over 24. But I have more negatives here. If I take a look at negative 4 compared to positive 2, that's going to make this answer negative 2 and 17/24. We'll just do one more example with decimals, although you probably wouldn't need to. I bet you know exactly what to do, but we'll take another look. Okay, in this example, we start with the number m and we subtract 6.2, so we have to get m by itself, we have to add 6.2, and that gives me a 0 pair here. And if I add 6.2 on the left side, I have to add it on the right side. So now we're back to where we have a positive and a negative. It's like negative 8 plus 6. That would be negative 2. So that's a good way to estimate what your answer should be. You should get something close to negative 2. I'm going to have to find the difference between these two numbers and make it negative. And I'm going to put the 0 there. 2, 1, 2. And it's going to be negative 2.12. So that's an example with a decimal. And you should be able to handle everything you have in this lesson.